Cray XMP and iOS Module Repair Procedures, Part 1. This is the first of a series of videotapes designed to set the guidelines for module repair. You'll need the following documents to review this videotape: a Cray XMP iOS Lab Manual, HTV 0829, and the manufacturing process documentation that accompanied this videotape. This tape will show 5 different procedures. Procedure number 1 covers chip removal and replacement. Procedure 2 covers resistor component removal and replacement. Number 3 covers resistor board removal and replacement. Procedure number 4 covers connector removal and replacement. And number 5 will show tearing down a single module. Before you begin, always be sure that you are properly grounded. You must wear an anti-static smock and wrist strap. Approved ESD shoes or heel strap are also required. You'll use a soldering iron for all of the procedures shown in this series. Begin by turning the dial on the soldering iron until the light goes on. When the light goes off, turn the iron up to 600 degrees. Always solder at this temperature when you are using low temperature solder. For all procedures in this videotape, you will use low temperature solder unless instructed differently. For good heat transfer, it is necessary to keep the soldering iron tip clean and properly tinned at all times. Also, keep the sponge at the iron stand wet and use it to wipe the iron off. This will keep the solder from sticking to the iron. You'll also use a solder sucker for all of these procedures. Check the solder sucker before using it. To clean it, remove the tip and empty the tube. Also, check the filter on the end. It will need to be cleaned periodically. Press the pedal on the floor to turn the solder sucker on. Be sure to keep the solder sucker running at all times when you are using it to prevent loose solder from falling onto the boards. Also, make sure you clean the tip of the solder sucker on the peg after removing solder 2 or 3 times. One final point: never allow the soldering iron to touch the tip of the solder sucker. The solder sucker tip is made of Teflon and will burn or melt shut if it comes in contact with the soldering iron tip. Now let's begin Cray XMP module repair procedures with procedure number 1, chip removal and replacement. Chip removal and replacement is basically the same for gate array, MOS, and ECL memory. The first step is marking the failing chip with a sticker. After marking the chip, locate pin number 1. It's marked by a dot on one corner of the chip. Place the iron tip in front of this chip lead where the pad and the lead meet. Heat the solder and remove it with the solder sucker. Repeat this procedure for each of the leads except the power and ground leads. Power and ground leads are difficult to remove. To remove a power or ground lead, first remove as much solder as possible. Then add flux and additional solder for better heat transfer. Now we'll remove the solder from the other leads. Remember to clean the solder sucker tip after removing solder 2 or 3 times. Once again, you may need to add flux and solder to remove the power or ground lead. When all the solder has been removed and the pins are loose in the barrels, use tweezers to gently lift the chip out of the pad. Be careful not to damage the foils underneath the chip. After removing the chip, remove any additional solder that may still be left in the barrels. Removing the solder will make it easier to install the new chip. Clean the area with Freon. Inspect the board for damaged pads or lifted pads. If the board is damaged, refer to Manufacturing Process Documentation 1017 for instructions. If the board passes inspection, you can install the new chip. Using tweezers, carefully place the leads into the barrels. The chip will only fit in one way on gate array and ECL memory chips. For MOS chips, you'll need an assembly print to properly place the chip. Now, using a piece of solder, add flux to the pads. Place the iron tip in front of the lead and lightly on the pad. Add a small amount of solder. Do not leave the iron in place for more than 3 to 5 seconds, otherwise the board could be damaged. Repeat this procedure for each lead on the chip. You may want to turn the module to gain easier access to the pins. Always add flux to the pads, and do not leave the iron in place for more than 3 to 5 seconds. When the chip is completely soldered in place, clean the repaired area with Freon. Make sure you remove all the flux from the board. Carefully inspect the repair area. Inspect the area for cracks, pinholes, and cold solder joints. This procedure is also covered in the Manufacturing Process Documentation 1063. A note about MOS chips. If the gold leads of the MOS chips aren't pre-tinned, don't use them. The leads can be pre-tinned by hand, but they must be tinned twice. This completes the procedure for chip removal and replacement. Procedure number 2, resistor component removal and replacement. There are 3 leads to a resistor, 2 outside leads, and a center lead. To remove the resistor, first remove the solder from the 2 outside leads. The center lead is a negative 2-volt pad. Like the power and ground pads on a chip, it is difficult to remove. Add flux to the center lead for better heat transfer. Then heat the solder in the center pad and use tweezers to carefully remove the resistor. Now remove the extra solder from the negative 2-volt pad and clean the other pads. Always clean and inspect the repair area before inserting the replacement resistor. Now line up the 3 outside leads with the pads and insert the replacement resistor. Add flux to all 3 pads. And solder in the 2 outside leads. After the outside leads are soldered, solder the center lead. Once again, clean and inspect the solder joints. This completes the procedures for removal and replacement of resistor components. Procedure number 3, resistor board removal and replacement. On more recent modules, resistors are no longer discrete components. The new resistors, also referred to as omegas, are built into layer 2 of the board, and their removal differs from the previous removal and replacement procedure. You'll need a number 36 or number 38 engraving tool and an ohm meter for this procedure. You should also use a diagram like this one to identify the cuts you'll use. Here you can see the 4 possible cut combinations which can be made. If it's possible, choose a cut combination that won't destroy a foil run. To make the first incision, get as close to the pad as possible without damaging it. Then start down into the board and slowly come up. After each cut, make sure to ohm between the center pad and the outer one being cut. This will prevent the board from being overcut and severely damaged. When there is no reading on the ohm meter, make the second incision. Again, ohm the pads after each cut. It should take several attempts before you open the resistor. The resistor is completely open when you receive no resistance on the ohm meter. Now fill the cuts with permabond. The permabond will prevent any shorts from developing. When the permabond is dry, remove the solder from the pads. After removing the solder, clean and inspect the repair area for damage. Now you can solder in a new resistor over the top of the resistor board. Clean and inspect the repair area. If a foil run happens to run between the pads so that no one cut is possible, use the following procedure. First, cut away as little of the foil as possible, making 2 cuts in the foil run with an X-Acto knife. Then carefully peel the foil off the board. Now cut off the resistor using the guidelines stated earlier. Remember to ohm the pads after each cut. Fill the cuts with Permabond. Then replace the foil run. Cutting and patching of foil runs is covered in Part 2 of this videotape series. After you've replaced the foil run, thoroughly clean the repair area with Freon. After cleaning the area, remove the solder from the pads and install the new resistor. Solder in the new resistor. Then clean and inspect the repair area. This completes resistor board removal and replacement. Procedure number 4, connector removal and replacement. When a connector has 1 or more damaged or crushed pins, it must be completely removed and replaced with a new connector. First, lightly place the iron tip on the pad in front of the first pin. As the solder melts, remove it with a solder sucker. Repeat this procedure with each of the pins on the connector. After all the solder has been removed from the pads, check the pins to make sure they are loosened and can be removed. After checking the pins, use a jeweler's screwdriver to remove the 4 screws from the connector, keeping your finger around the bottom of the screwdriver to protect the module. When the screws are removed, gently rock the connector back and forth until it releases from the module. After adding flux to the pads, remove any excess solder. Then clean up the module with Freon. Now install the new connector on the module. Reinsert the 4 screws. Tighten the screws about halfway down. Check the pins and make sure they are correctly aligned with the pads. Then place the module into the alignment jig. On one side of the board, line up the guide pins with the corresponding holes in the jig. Then carefully turn the module over. Make sure that all the pins on this side are also in line. If all the pins are correctly aligned, push the module the rest of the way into the jig. While the module is still in the jig, torque down the screws. Torque the screws down to 7-inch ounces. Then remove the module from the jig. Run a thin coat of flux along the connector pins. Now you can solder in the new connector. Heat each pin by placing the iron tip on the pin in the pad. Then add a small amount of solder. Repeat these steps with the remaining pins. Afterwards, clean and inspect the repair area. This completes the steps for connector removal and replacement. Connector replacement is also covered in Manufacturing Process Documentation 1017. Procedure number 5, tearing down a single module. The first step in tearing down a module is removing all of the cage wires. Cage wires are interboard jumper wires that connect the A and M sides on single modules. Cage wires are shaped like small nails and are also called nail heads. To remove the cage wires, place the iron tip on the nail head side. Heat the pin long enough to melt the solder on the A board. Use the solder sucker to remove the cage wire. Use this method to heat and remove each pin. Keep a contact sheet nearby to properly log cage wire removal. The contact sheet must match the module by name, glass date, and revision. Remember to mark the contact sheet after each group of cage wires has been removed. When all of the cage wires and solder are removed from the M board, turn the module over and remove the remaining solder from the A board. Then clean and inspect the module. You are now ready to tear the module down. Always begin by removing the bus leads. Remove the lock washers, flat washers, and nuts from both bus leads of the M board. After removing the hardware, remove the lead from the module. Now remove the 4 screws in the connector and the 2 in the test point. Remove the nuts and flat washers from each inner board stud. Make sure that you only remove the hardware from the board needing repair. When all of the hardware has been removed, lift the board off the cold plate. Lay the removed board chip side down on a grounded surface. Inspect the circuit board for cold solder joints, open foils, or excess solder. These procedures are covered in Manufacturing Process Documentation 1063. Also inspect the cold plate for gouges, scratches, or dirt. Clean off any residue you may find. And fill the scratches and gouges with Permabond. Before placing the board back onto the cold plate, make sure all the gold washers and connector and test point shims are in place. Next, place the board on the cold plate. Then put the flat washers on the studs. And place a small bead of Loctite on top of each stud. Thread the nuts down, tightening them halfway. Also, put a small bead of Loctite in the connector and test point holes. And quickly insert the screws. Tighten them halfway down. Next, insert the bus leads. Insert the screws for the bus leads. Always put the head of the screw on the A side of the board. On the M side, place the flat washers, lock washers, and nuts on the screws. Make sure that new lock washers are used each time the bus leads are reinstalled. If you aren't using lock washers, be sure to use Loctite on each screw, and remember to only tighten the nuts halfway. After all the hardware is on, insert the module into the alignment jig. Remember to check the alignment of the connector pins on both sides of the module. Using a torque wrench on each side of the board, torque all the hardware down to the required 30-inch ounces. Connector screws and test point screws are only torqued to 7-inch ounces. Next, replace all the cage wires using the contact sheet for proper placement. The nail head end always goes on the M side on single modules. Solder all the cage wires in on the M side. Use only enough low-temperature solder to cover the head. Clean and inspect all the solder joints on this side. Then turn the module over and solder in all the cage wires on the A side. Finally, inspect all the solder joints and clean the module. This completes the procedure for tearing down a single module. This ends the first part of the Cray XMP module repair videotape series. Review this tape as often as you feel it is necessary.